Good morning. Get that under control. Good. All right. Hope everyone's doing well. Today I am still working on my binary search tree implementation. Yesterday spent some time performance testing my insertion add method and optimizing it and comparing it to another BST implementation that I found out there. And I am satisfied that we've optimized this reasonably. I'm a bit slower in the cases where the tree gets quite a bit bigger. Um, and I can't really tell why, because having looked at our algorithms, they're really similar. So I suspect it's something to do with the garbage collector and, memory, basically behind the scenes JavaScript engine stuff that I really don't have much control over, and it's hard to understand what's going on. So, but still, I mean, the performance is adequate. Um, Here, let's take a quick look. Let's say I wanted to do, we'll make it 100,000 items, right? We're going to be pushing 100,000 items to the binary search tree, random numbers. And if I do this, and that's that, right? So the other implementation, Bassarat's implementation, took 37 milliseconds. Mine took 72. If I bump it up to 1,000,000 items, obviously going to take a bit longer. So his implementation takes about 800 milliseconds, and mine took 1.1 second. So pretty close, all things considered, and we're talking about a million items here. So I think that's quite usable, right? So I'm going to move on to testing now. Let's see. Going to be testing the performance of the has method, which obviously searches through the tree looking for a match. So let's do that. So we already, what are we doing here? Okay, so we already have we're populating our trees, so that's done. Then all we really need to do is pick let's see. Well, I could run a has for every single item. Yeah, why don't we do that? So basically the same thing. So const item of random ints. Then let's start with Bassarat's BSD dot. Is he using a has? No, he's not. I think he's using a search. Search looks for the value with the provided search key, returns the value found or undefined if it wasn't found. Right, because it's a BST tree. Actually, what am I using here? Am I using his implementation of BST BS tree? No, okay. So I guess element number. Let's take a look at the rest of his API. Clear contains. Okay, returns true if this tree contains the specified element. That's what we're going to use. So tree contains item. We're not really interested in the result. Now, would it make sense to try some operations where we would look for something that is not contained in the tree? Um, that's an interesting proposition. It would force an entire traversal of the tree, and that's kind of an important benchmark. I get, well, we'll get the same thing. We'll get the same from just looking at it. I mean, we're going to be looking for items that are at the very end of the search tree. So we're going to be testing traversing it in its entirety. MyBSD.has item. That's that. And then we can just do, I could have just copied this. Would have been faster. So why don't we do that? Let's do that. And then just change that to contains. And change that to random contains. Contains. And then copy mine. Like this, and this will be has, random has. Okay. Let's take that for a spin. I'm really curious to see. Oh crap. I left it at 1,000,000. This might take a while. Well, not that bad actually. And I guess it makes sense, right? Because the add function actually has to traverse the tree as well, right? So in the end, in both cases, the has function is a bit faster than the add function. Let's run it again. Yep. Cool. Now, I mean, I'm satisfied with that. Let's take a look at a smaller sample. Let's say we just had a hundred items. All right. So I'm actually faster in the adding, the insertion, and I'm a bit slower in the has or contains. If we were to bump it up to 1,000, I'm a bit slower in both, but still, I mean, 2 milliseconds for 1,000 items is not that bad, I would think, right? Okay, so let's keep it like that. I could take a quick look just to see if there's anything that pops up, and that seems obvious that can be improved upon. Oh, there's an interesting thing I could do, right? Because I am using recursion here in order to search for so maybe if I were to write this imperative style, it'd be interesting to see if it's faster. Why not? Why not? Let's try this. I think I had an implementation here. Deletion, traversal. Well, I guess traversal is searching. Okay. There you go. I've got an example of let's see here. There we go. Okay, I'll bring that in right here. Like that. Get rid of this. And give us a bit more space. So we've got a recursive iteration search, and we've got an imperative iterative implementation here. Okay. So, what are we doing here? Okay, let's start by just making another search function that we're going to call search iter. Delete everything in here. So in the recursive one, we are looking at the root. If there's no root, return, because obviously the tree is empty and we don't have the value we're looking for. If the root value is equal to the value we're looking for, then we found what we want. Cool. Just return the root. Why do I need to return the root? Do we care about returning the root? Let's see. Has returned this dot search. If this dot root is equal to undefined, right? So we're returning it because it's expecting. Yeah, I see. Oh, and I don't have a choice to return the root because if I don't, where am I now? I'm lost. Where's my search? Okay. We have to return something to unwind the stack as we're going deeper in. Here we go. Right. And if I find no root, then I just return. But I could return false or true. Wouldn't make more sense. Because I really am not using this. Yeah, why don't we do that? Not like we're going to save much on performance here, but let's just do a Boolean here. And if root returns false, then return true. Simple as that. Let's just make sure we didn't screw up the whole thing. Start quokka on the current file. Let's get our thing going. Then bst.has 13. And the verdict says true. We do have 13. Do we have 11? We do. Do we have 14? We don't. How about 15? That's right. 18? Yep. 20? 21? Yeah, 2? Okay. We're good. We didn't break anything. I promise I will make automated tests for this eventually. And we're done with this. Okay, so it's nice and simple, right? How do we do this with iteration? Oh, I want to compare my implementation to what they have here. If node is node or node.key equals key, return node. If key is smaller, return search recursively key node dot left node dot right. Yeah, essentially what I've got. Okay. Okay. Let's see here. So we're storing the node in something called the current node. While the current node is not undefined, I guess this is Python. Is that Python? Yeah, Python. So if the key is equal to the node key, so the key we're looking for, if it's equal to the node key, then we return the current node. If the key is smaller, then we just say, yeah, okay, I get it. Pretty simple. Current node is equal to our root, I guess is what we're calling this. Oh, let's change this to just return a Boolean. Boolean, please. Thank you. Current node. So while there's a current node. Actually, I think this is better for performance. While current node is not undefined. Okay. Then what do I do? If the value is equal to current node dot value, but I need to use my compare function for this because I don't know that the value could be an object. It could be so this dot compare function. We're comparing the root value to the value. Nope. Sorry. The current node value to the value. If they're the same, so if equals 0, what do? We just return true, don't we? Because we found it. Now, if this dot compare function, the current node is bigger, current node and value. Current node value I need to compare, yep. Current node value is bigger than 0. When bigger than 0, we need to go down. If the current node value is bigger than the value, we go down the left child, right? So I would do current node equals current node dot left child, I believe. What seems to be the problem here? Cannot assign to current node because it's a constant. No! That's not what we want. Good. And then else obviously means that we are going down the other side. So current node dot right child. Okay. And if we do the entire while loop without returning true at some point, then we're just returning false. All right, not quite as elegant. A few more lines of code. Question is, will it be faster? And that's going to be interesting. So we're going to make, what have I done? Does not exist on type true. Well, that is interesting. Crap. I guess I didn't think about this. So there is a reason why I was returning something. It's because the remove function was using it. Okay. Not that hard to fix, my boo-boo. Then I just return. Then I just return. What do I return? What was I returning here? It's going to be root value is equal value. I return root. No? Oh, yeah, okay. I think that's right. And we're going to do the same thing here. Let's see. So instead of returning true, I am returning the current node, because that's the one I found. And if I complete the entire while loop and I didn't find what I was looking for, I would return simply, well, I don't even need to return, right? It'll just automatically return undefined. All right, I think I have fixed this problem, but just make sure we didn't break anything. Let's do a quick test again with our friend Quokka, bsd.has 13 or 12. 12. I get undefined. Oh, right. I have to change this again. So return this. Just that search. Return this dot search does not equal undefined, right? And now, where we go, we're in business. Do we have an 11? We do. Do we have a 10? We do. Do we have a 6? We do. Do we have a 19? We don't. All right, good. All right. Just had to be sure. Now, search iterative. Okay, I think we'll be good. Let's make a has iter value of type t, expecting Boolean. Essentially the same thing here, except that we're using search iter. And now let's test it here too before we go on with the performance testing, just to make sure it's doing what it's supposed to do. Has iter is the one we're going to be using. Does it have 13? It does. Does it have 10? 110? No. 10? Yes. 20? 220? What? 20, 18, Yeah, okay, we're good. Good stuff. That's right at the bottom. Okay. Now, let's turn off Quokka. And I guess let's test this for performance. I will, for starters, just change that to has iter. See if there's any obvious difference. How many do we have here? 6. I think this was, yep, these two here were, so I was getting around a second. My as function was getting around a second. For a million. Okay, let's see what we get now. Inconclusive. But I would tend to say maybe a bit faster. Let's run it again. Yeah, hard to say. We seem to have a bigger difference between the add and the has. Just want to make sure I did this right. Search iter. Yeah, and this is just search, and I'm using has iter as using. Okay, good. One more time. Yeah, I think I might be faster. Okay, let's try actually both side by side. But I have found for some reason that this, probably because I'm using the same class or something, I found this to be misleading. But it'll be interesting to see, nonetheless. So let's remember that we were getting about 960, 950 before adding this other case. So we do seem to have a slight improvement in performance in the case of our has iter. Yep, in the order of about 100 milliseconds. Now, let's see. If I were to change the order here, kind of trick the JavaScript engine, because I think sometimes like it sees that it's the same similar kind of code is being used a lot, so it kind of optimizes behind the scenes, and then the second function kind of gets a performance boost. I'm not sure about that, but I have a feeling that that's what has happened in some of my tests in the past. So let's see if this changes anything. Not really, no. So we're still getting a performance boost. Okay, so that seems pretty conclusive. In that case, we will make that the actual implementation that we're going to use, so we can forget about this here. Like that, and we can we'll just say, okay, we'll switch that to search, and we'll delete this one. There we go, shaved off a little bit of time. Mind you, that is with a million items. I didn't test it with less items, but I guess with less it doesn't really matter all that much. So, anything else we could optimize in here? I don't see it, right? There's just, well, there is one thing here. Logically, we're going to get to traverse a lot more nodes than find, and this is going to be, this here is going to be true much less often than this and this. So by making this the last case, we might be saving a little bit on performance, right? Because I hope the JavaScript actually short circuits when it sees an else. Well, yeah, right, it doesn't actually go and evaluate whatever's next for no good reason. So yeah, let's switch that around a little bit. Is it worth, yeah, okay, hold on, let's bring this back. Let's bring this back. And we might as well bring this back too. Here we go, let's make sure that didn't break everything's good here. Yeah, okay. So just for kicks, since we brought all this back, let's try it with like 100 items. See if there's a performance difference between the two. Haziter is still faster. Oh, not in this case. See, that's the thing, right? It's kind of, and again, slower. Now, what if we were to switch back the order that we're actually using them? Ah, now it's faster. And now they're both equal. And now it's faster. So, all right, whatever. Doesn't make much of a difference on the smaller number of items. Now, what I wanted to test was if we were to, let's see. So we decided we weren't going to go with the recursive option. We're going to go with the iterative option. And we wanted to try, this will be our testing thing. So we wanted to try to see if there was a difference between changing up our conditionals. So instead of checking for this first, we would be checking for if. This compare function Yeah, it's just the same as this, except we're going to be checking for smaller than 0. And if that's the case, then we do current node is equal to current node dot right child. Good, I can get rid of this for now. Or actually I can just take this right here, shove it in there, and get rid of this entire thing. I just need an else here. Bring that up like that. So if, and then current knows that, otherwise this, otherwise that. All right. Make sure this actually works. Iter. 21, true. 22, false. 13, 10, 6, 7, whoa. Oh, okay. 6, good. Was going a little too fast for Quokka. All right, so this works. Like that, stop Quokka. And now we should be good to, do I need to change anything here? No. Just have to remember that has iter is the one that we're testing for the change in order of the conditionals. Interesting. It's coming in slower. Ha. Okay. Let's try that again. Yep, it's coming in slower. Let's change this here. So was I wrong about my assumption? Yeah, all right, well, let's forget about that, eh? So I can get rid of this here. And I can officially declare a winner. I'm still not quite sure why that would be, though. Well, I mean, obviously, oh, there is one thing we could do that might improve performance a little bit. Okay, let's bring this back. Now, so far, we've determined that this was faster. But this might be because we're calling this function twice here. Oh, we still are calling it twice in this case. Okay. Let's use that as the base. And really dealing with micro optimizations here. What we're going to do is instead of calling this twice, and I have done this in, so we're going to call this const compare value is equal to this. And then all we're going to do here is compare value. Value. And then compare value. Oop. I forgot to bring back our has. Iter. So let's has iter. Search iter. Okay. Performance testing time. I deleted it, didn't I? Let's bring it back. And test. Oof. Probably too close to tell conclusively which one really is faster. Actually, D1 that doesn't do that seems to be faster right now. My previous implementation, which is very interesting. Of course, it depends on the speed of your compare function. If it was really heavy, then it would be faster. So it might be worth leaving, still going with this, because if I had like a really complex and I can actually test that out, I think I had done that before, but let's just have fun with this again. Oops. Return this. And then there's just, you know, for, let's make it a while. While count is bigger than 0. Do nothing, or actually decrement count. And let count equal 100. Let's say. Don't want this to take too long. Who see has quite a bit of a performance impact. Oh, and there we see it. See? Ends up being much faster that way. So that was a good catch. Good catch, Phil. Good catch. Let's leave that in there for future use. And it's interesting to see that when we get the compare function a bit more complicated, the performance discrepancy between my implementation and Bassarat's implementation is pretty much gone. And we are testing with the simplest compare function possible, which is just comparing numbers. In reality, we might be using this comparing strings or complex objects or whatever, so it's a big factor. All right. So I'm satisfied with that. We're going to be keeping this one here. This one's gone. All right, before I go and delete everything again, let's see if I can think of anything else that could be an optimization. wonder now that I have switched this around. If I were to, no, I think that's fine. Okay, let's roll with this. Micro optimizations are done. I think we're good for that. Get rid of this here. And let's move on to testing. Maybe, let's see. What else are we going to test here? The remove function. Yeah, that's going to be an interesting one. So first we test that how fast we can add stuff to the array. Then we test how long it takes to determine if something's in the array. And now we're gonna empty the array slowly, one item at a time. That'll be very interesting. Am I gonna use this sorted ins? I might later, so let's leave it there. Now let's just copy this. Boom. And now this is going to be remove. Removes the specified element. Yeah. So we have the same API there, I think. Yep. And random remove. 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 And let's run this. Oh, I am faster. That makes me very happy that I am faster. Let's try it again. Yep, I'm a bit faster. Still can't figure out why I'm considerably slow at adding though. Really don't get it. We basically have the same algorithm. Somehow the engine doesn't treat it probably has something to do with memory allocation, or I don't know. But I mean, our implementations are very similar. All right, so cool. We're a bit faster in terms of removal. Maybe I should test to make sure that we didn't screw up anything with the remove function. With all the changes we've been doing around here. All right, so let's get rid of this for now. So we have a BSD size of 7. We do have 13. Now if I am to remove 13, I would end up with, it works, then I do has 13, and I should get false. Cool. And the size should be 6. Yeah. And let's take a look at our actual tree. I don't need this here for now, so let's make some room a little bit. Let's take a look at our tree here. Our root used to be 13, now it's 18. Right, because it went and it got this, and now 21 should be the right child of our root. Right child is 21. No, that's not right. Hold on. If our root is now 18, the right child is 20. Okay, that's right. 20, right? And its right child is 21. Its left child should be nothing. Oh, and it is undefined. Good. Cool. Parent should be 18. All right. And we don't have child, 18, 20, 21. That's right. And if I go and look at the left child is 10, and its left child should be 6. Yep. Its parent should be 10. So left of left, that gives us 18, 10, 6. That's right. And this should be 11. All right. It's good. Everything's fine. Everything works in terms of implementation. It's doing what it's supposed to do. So that's pretty cool. Don't ask me to explain why we're faster in this one and not the other ones, but quite satisfied with this, and I won't waste time trying to, well, let's take a look just for fun, see if we could find something that pops. And it seems very obvious, and that we can optimize. Actually, there might be. There might be. Let me take a quick look at our examples here. Can't remember where I found the inspiration for this algorithm, but let's take a look here. And insertion, deletion. Now this is the recursive. It's pretty much just the place node in parents, binary tree. Okay, binary tree delete. It's not recursive now. So what are we doing here? Well, it's similar to what I'm doing. Except the order is different, right? I'm making more checks than I might need to if I change things up. So I think let's create a new remove. Call this remove candidate. And so let's see, let's run through this here. What are they doing? If the key is smaller, so they're checking for smaller here. I have my node here at the beginning. I'm looking for my node. Find min. Yeah, we're doing this quite differently here. If key is smaller than self.key, self.left child binary tree delete. Binary tree delete key. Oh, they are calling this recursively. Kind of. Right. So essentially, this is their find. Okay, I get it. This is their find. This is how they find. If self the child is the right child, if both children are present, then the successor is the min. This short circuits if the key is less than the key. Call self.left child binary tree delete key. So you'll be recursing until blah 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 blah. You'll find something other than these. Right? If just easier to read like this. Okay, if delete the key here. That's right. If both children are present. Yeah, and this doesn't deal with the case where it's the same, or no, okay. This just recurses down the tree. Do we need to go left? Do we need to go right? If it's equal, then it skips these, and then we deal with this. Right. Okay. So essentially this here gets me to a position where self is equal. Which is what this does here. Okay. And then they're checking for both. If self dot, so that's the opposite of what we're doing here. We're checking if both aren't. They're starting by checking if both are. That's interesting. So let's see. Let's try to switch this around. We'll just do that. So if I wanted to check if both children are present, which in a binary tree would be the most common case, right? So if we're basically using this here, like that, like that. And what did we do? This is what we did. That is what we did in here. Looking for the successor, finding the minimum. Is that what they're doing yet? Find them in. There you go. And self.key equals successor key. Note that value equals successor value. That's the equivalent of that. And then they are calling the binary tree delete with successor key. Oh, yeah, okay. They're calling the whole thing again to delete the, which is probably not all that performant, but I'm doing this here. I like better. Okay. And I'm returning true right there. Okay, and now they are looking for left child and right child. Now I don't need to do an else because I have a return statement in there, so that's cool. So I can just do if, and I'm only looking for the case where I have a left child, which is essentially this here. You can just copy this. If no.left child. I already know that you don't have both if we're here, so. And then I can just do the same thing with the right child, which would be this one. Okay. And that's all my cases, really. So I don't even need an if statement here. What is this, though? Else self-replace node in parent none. This node has no children. Ah, okay. I'm dealing with that at the... Oh. In the case that there are no children, how am I dealing with this? That was the case right here. All right, so I should have 4 cases. How many do I have right now? 1, 2, 3. So let's just get this right. Okay, and the fourth case is this one here. That is the one where I don't really need to have an if. I can just go boom. All right, let's delete this. Like that. Don't need you for now. And I can I can test this using our friend Quokka just to make sure that it works. And we're going to use remove candidate here. True. 13's gone. Let's take a look at our tree. The root is now 18. Its right child is now 20. The left child is 10. 20. His parent is 18. 20 is our child, which is 21. Cool. Now how about we try removing. Actually, I'm sure it's fine. Okay. Famous last words. Okay, now let's test to see if there is a difference by changing the order. So random remove candidate, remove candidate, remove candidate, and let's do this. What? No, that can't be right. That is, oh yeah, of course. That is so, I'm so dumb. Yeah. It's because I have removed all the items from the tree, so I would need to add them back in. So we're going to do that. I'm not gonna here. Adding them back in there and then testing. Okay. Interesting. That seems to be slightly slower. Let's run it again. But I mean, probably too little to really tell. So, okay. And let's switch them around just to see if it's some kind of weird optimization. So far, remove candidate has been slightly slower, like really, really just a bit slower. Yeah, this seems to be the case. So goodbye, remove candidate. Don't need you. Looks like my original idea was faster. Okay. Anything else that pops up that we could change? True, 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 false. Would it be beneficial to not return true here? Use a bunch of else ifs instead. And just have the one place where we change the size and return true. Well, we won't know if we don't test it. So we're bringing you back. There we go. Now the idea was, okay, we've established that this here, though, is faster. So we're going to use that. But instead of returning true, 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 and this size minus, this size minus, we're just going to use a bunch of else if. Else if. Let's bring that in here. Else if that. Else if this. And then else do that. And then at the very end, you can decrease the size and return true. Okay, makes for a smaller function. I don't know that it's faster though, but let's find out. Well, does seem a little faster. Might be shaving off a little bit of interesting. And let's see if we are to switch those around. And do this. And now our move candidate seems to be slower. Ha! See, that's what I was talking about. Now that it's after, it's slower by, let's call it 14, around 15 milliseconds. Oh, this one is like 22. 23. So it's consistently a bit slower than our regular remove. Right? We agree with that. 15 to 20 milliseconds. Let's run it again. Yeah. Oh, now it's faster. Yeah, so inconclusive, I would say. Well, let's run it one more time, just for kicks. And now it's faster. Oh, okay, I would have to run this for like a long time to really figure it out. Many, many times. But, okay, so we have a choice to make. Which one do I prefer? This is less lines of code. Right? We have less duplication in this one here. We're just returning once. We're using the size. We're modifying the size only once. But this, for some reason, seems easier to read. That's because it's all separated. I could probably do something about that here. It's more of a JavaScript thing where we usually have the if statement on the same line as else. I think I'm going to stick with this one. I'm going to use the candidate. Anything else I would change in here? Anything else I would change in here? Nope, I don't think so. So let's use it as our final choice. Like that. And just make sure it all works properly. Just remove 13, that's right. Now the root is 20, nope, that ain't right. Root is, 18, good. I don't know what I'm seeing here. Root is 18, left child should be 10, the right child should be 20. Okay, everything seems fine. And the right child should be 21. This one should be the parent. Good, 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 good. Stop. In the name of... Okay. All right. So we've got to remove. Done. Let's get rid of this here. And I think anything else I should test in here? Add has, remove. The iterator could be interesting. And then I could look into adding some functionalities to this class. Now that we have a solid base. Iteration. Does he even have? I don't think he did that. I am so much cooler. Oh no, that's not it. Hold on. This dude here. Let's see, where are you? There we go. That's kind of the library I'm kind of competing against, if you will. It's a really nice library, actually. The APIs are quite nice. It's well documented. Now, I don't know. I haven't tried comparing my... So he's got a stack. He's got a... Why he implemented his own set, I don't know. It's built into the language. So I don't really know. Okay, he's got intersections and unions and okay, so that's cool. That's one thing I could think about doing too. It's too bad that JavaScript doesn't have that built in. Oh, let's see. You're saying the built-in sets in JavaScript don't allow custom hash functions. But why on earth would you want to do that? And I don't think this implementation does that too, does it? Optional function used to convert elements to strings. Oh yeah, it does. If you need to create a set of complex data structure and not primitives. So what are you saying that V8 or whatever JavaScript engine you're using um, doesn't do a good job of hashing keys that aren't primitives? So if you let's say objects, let's say you're using well, I mean they're not keys, right? The values in a set, but the same would probably apply with the map. So you're saying that if it's the spec that's the problem, it's too liberal. Okay. So you have implemented a hash function in your own custom set class that for a certain type of object was actually faster than the built-in set, is what you're saying. In practice, if you write your own, you can achieve both better performance, cleaner API, and other things. Really, really interesting. But in very specific cases only, right? I doubt that if you're using primitives, you'll actually be faster than the built-in. Writing your own stuff turns out to be faster than built-ins a lot of times. Example, the map function on arrays is slower than making your own map function. Interesting. And why would that be? It's because the spec includes additional mandatory work that the map has to implement. Right. Stuff you might not need. Additional overhead. True, 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 true. Especially if you're, if you're writing it for very specific cases, I guess yeah, you can super optimize for your specific case. But if you're trying to do something that is kind of general use, right? Like if you're trying to do a data structure that you're going to be able to use for many different kinds of types and situations, I'm thinking it might be hard to do something that's better than uh, the native JavaScript data structures. But there were also some times where the native methods did not inline properly in V8. Interesting. You can always do better data structures in pretty much every language. Really? Really? Well, you know what? Let's put that to the test. We could take a look at this set implementation and compare it. Let's see, do I need to keep this here? Yeah, I'll keep it. I'll just maybe just comment all of that out. Don't need this anymore. Most cases it may not matter though, and shipping more code is something you usually want to avoid for JS in the browser. Yeah, that's a good point. It's one thing to, if you're writing for Node, if you're writing for the browser, you got to keep that in mind. True that. Maintenance cost is also something to keep in mind. So if we were to, let's see, const, what is this thing called? Collections. So let's just call it Bassarat. Bassarat set equals new collections dot set. Now let's start by just comparing it with built-in set. And let's do this here. We're going to be what did I call it? Set with 8. Okay. Add, okay, same API, good stuff. And built-in set. Just want to take a look at the right. Also add. All right, let's take a look at that. See what we get. I'm running this with 1,000,000 items. No such label. Whoop. Yep, forgot about that. And this will be built-in set. Built-in set. So that matches good. Let's go. So there is a huge difference. Of course, we're using primitives here. We're using numbers. But I mean, still. That is I would need to make a much more complex test if I wanted to use like objects or something like that. But it might be worth the one thing, never mind performance. And here's the weird thing. Let's see. He's using a dictionary. Okay, so basically a set is wrapping a dictionary is what I understand. And his dictionary is implemented how? Using this dot table. He's just using an object? It would seem. Just a plain object, set value. Dictionary pair, this table. Okay, yeah. It really is just using a plain object. That's interesting. Very interesting. At the least, I mean, he could, like if we were to take the case where we want to be able to supply our own hashing function because we're convinced that we can do better than V8 in the case of certain kind of types, like a complex object or something, which I'm not convinced. I'm not convinced. V8 is pretty well optimized from what I've seen so far. But let's say that that's the case. Then why not just wrap a map and use that for all primitives? And then do your own kind of implementation for whenever somebody supplies a whenever the client supplies a custom hashing function. At least you wouldn't hurt performance on those super optimized cases when you're using primitives. Just a thought. But anyways, there might be more to it. It's negligibly faster usually, unless you create specialized map sets that include extra constraints. What is negligibly faster? You mean when you do your own implementation versus native, built-in, or the opposite? Say you want to only support primitive keys and values and disallow objects, you can do faster than the native implementations. Really? In JavaScript? How would you go about doing that? Yeah, that I can see. Like maybe only support objects that I could see. Maybe. Maybe. But I don't know, even then because you'd write your hashing function in JavaScript, right? And then, compared to the engine's hashing function, which is all running in C++, I guess. Like, who knows how your hashing function is going to be optimized by the engine? It might be well optimized, it might not. It's doubtful that. I would have to see it. Do you have an example of a library that actually does that and gets better performance than the native data structure? If you write low-level JavaScript code, it gets jitted to very fast code. It's what the native C++ collections give you. Really. So give me an example of how, because that's really interesting. How would you, so you said that if you only support, let's say, primitive keys and values, let's just keep it simple and use a set instead of a map, so only values, right? Let's say I wanted to restrict my custom set class that I'm doing to only numbers, number primitives. That's all. That's the only kind you can get in there. How do I have to write this in a special kind of way that I don't fully understand? Is there something I'm missing here, or it's just a matter of making sure you're just putting numbers in there? Oh, you'd still roll your own hashing function, right? Okay. Right. I was forgetting about that. So it's a matter of if you're restricting the kind of values you have, that makes your hashing function simpler. And basically we're going on the premise that the hashing function used by V8 is complex because it has to account for the possibility of many different kinds of values. So what a lot of people would do is specialize collections for small collections because small collections are super common. Interesting. Super interesting. Is it worth it though? I'm guessing when you say small collections, you mean collections that contain, a small amount of items. Is it worth though uh, going through the trouble of writing your own data structure like that? It is usually worth it, really. But like, I mean, unless, yeah, I guess it depends what kind of application you're writing. So you use objects like interface tuple 1, T1, yeah, get it. Because those kinds of objects turns into structs and have array level performance. Yeah. So it would make sense to roll your own kind of small collection like that if you used a lot of small collections, right? Um, I'm guessing like, especially if you're writing like a game or something like that, but for just like a normal web app or other kinds of applications. Okay, statistics. Most programs use 95% collections of 10 or less items, right? But they use a lot of, right. Yeah, that's what I'm thinking too. But I can see what you're saying, right? Like if you can shave a few milliseconds here and there, it's definitely worth it if you're going to be instantiating a lot of those collections and adding and removing to them a lot, and which is like a, if you look at C++ collections, they actually have at least 3 implementations behind the API. Use different sorting functions, etc. Yeah. Well, the thing is, I thought V8 was doing that quite a bit too, right? I haven't gone through the entire source code, but from what I'm reading and a little bit of that I've seen, they do use different implementations in different cases. It's not just like a one size fits all. So they do take a look at, and they do optimize if they, for instance, with the array, I'm sure, I don't know about the map and the set, but I do know that in the array, they will look to see if, if all you have is numbers in there, then it'll change the way it deals with the array and optimize for that. So I don't know for sure, but I would think that if they have, if you've got a map, you're using the built-in map, and it detects that you're only using it with numbers, I would think that it'll optimize for that and probably use like a custom hashing function that is just like super optimized for just using numbers. It would make sense, right? Let's see. You're saying V8 has to make guesses at those, and those have to be conservative. You're writing actual code. It can make promises that are more predictable. Yeah. V8 optimizes a lot for 32-bit integers. Yeah. But it does not do so for the ES6 map and set last time I checked. Okay. That's good to know. I mean, but it's also evolving constantly. So they might at some point. I know I had done some performance testing on the set when it was just getting rolled out everywhere back in 2016, I think. And having done some more testing lately, the performance has changed quite a bit. They have optimized it quite a bit. But, who knows? Who knows? In either case, you need to support other engines too, and the write your own algorithm is the one that can give you good results across the board. That does make sense. That is, does it does make sense. At the same time, supporting other engines. I mean, what V8, if you include Node, V8 has like 90% of the market, if not more. And I'm pretty, yeah, especially since Edge, right? Edge is now running on Chromium, which is V8, right? Safari is super common. Sure, sure it is. Sure it is. But I'm guessing they pretty closely match each other. Might be some differences in edge cases, but so yeah, you're right. I agree with you. Safari is actually faster than V8 sometimes. They are doing a good job. Yeah, I don't doubt. I don't doubt. It's all about trade-offs, right? So if one company decides to optimize one thing, well, chances are that they are kind of de-optimizing another case. But in terms of what I'm trying to do here, I'm trying to build a library for fun, by the way. This isn't, I'm not expecting anything to come out of this. It's more my personal use and just for learning. I'm trying to build a, yeah, man, don't get too distracted. No, this is great. This is great. You know, it's nice to bounce things off, you know, other people and other ideas. And when you're all alone, sometimes you're in your head and you go down a certain path and you're like, oh, I think there was a better way to do this, but I'm not. Yeah, okay, so in terms of what I'm trying to do, goal number one is have a super general, general use, generic collections library. I want to leverage the built-in um, data structures and collections because that A will save me some work. B, it's relatively well optimized for general cases. Let's put it that way, and that's what I'm doing, right? I want this to be for general use, and I want to the main reason for doing it is just to have maybe a nicer API. For instance, right, like the array in JavaScript is super well optimized for using it as a stack, right? The push and pop functions are like pretty well optimized. But let's say you want to use a stack in your code, and so you use the array, but then you end up with like a super wide API, right? You can push, you can pop, you can shift, you can. But all you really should be doing with this, and you want to make sure that everywhere in your code, this is just a stack. It's only supposed to be a stack. Push, pop, that's it, right? It's a kind of a danger to use the array. Well, it's not a big danger, but whatever. It makes it more obvious if you're passing in a stack than just a full-on array. So that's one of the thinking behind that. I want to have more specialized APIs. And where it makes sense, actually add some stuff. So I like the idea, for instance, here of the set that he's using because he's implementing because he implemented some operations there, which I really don't understand why JavaScript didn't do that. Having unions and intersections, it seems like one of the most, like the biggest reason to use sets. Python does a pretty good job of that. I don't know about other languages. Oh, sorry, I missed your message. If you want something really interesting to work on, you may want to look at persistent data structures. Yeah, I was looking at that the other day. It's interesting stuff, and I might move on to that eventually. But for now, I'm starting with the basics, you know, and I'm going to build onto that. Here's one thing I might might get some feedback on. I was thinking, right, if you're using a by the way, in practice, it turns out that using many different specialized collections may actually slow down your code because you may need to convert between them between modules. That's a good point. That's a good point. Yeah. All right, so here's my idea, right? Using a binary search tree. So idiomatic use of data structures where you just restrict the API with, say, TypeScript is a good solution to that. Yeah. It's kind of what I'm doing. Okay, so binary search tree, which is what I'm kind of working on right now, is really good for anything that has to do with sorted stuff, right? But it's slower than a hash table, a map, or a set in JavaScript in terms of insertion and deletion and checking if it has a certain element, which are all O of 1 in a set or a map, if I'm not mistaken, usually. And I think they're O n log n in a binary search tree, I think. Anyways, what if you had some sort of data structure that wrapped both a map or a set, whatever, a hash dictionary, whatever you want to call it, and a binary search tree. So when you used it to add, you would just basically add to the set, and then the data structure would return control to you, and kind of behind the scenes, so that I guess it would have to be using concurrency threads or whatever. So behind the scene, it would like add it to the binary search tree. So it's basically like a 2-in-1, but you'd get O of 1 for adding. Well, kind of O of 1 for adding, I guess, and removing and checking if it contains something. But whenever you needed to do stuff that was related to anything that has to do with the sorted functions and stuff like that, then it would delegate to the binary search tree. I don't know. Would that work? Does that make sense? Would there be like just way too much overhead and it wouldn't be worth it? It would be hard to implement in JavaScript. I didn't really think it through, but like if I tried to do that using threads, then you probably, yeah, for sure, you could only use it. You could only do that with primitives, because if your value types were objects, well, no, it would be fine if they were objects without any methods, I guess. Because the transfer between threads in JavaScript, you can't, I think you lose, it strips the methods. Or you would need some sort of code that would rehydrate the, that would get complicated. It's just like, you'd have to build some sort of DTO to transfer between threads, and then when it comes back, it has you kind of rebuild it into the class. Wow, that would be insane. I don't know. Ideas for later, maybe. With shared memory, yes, but only using array buffers, right? If I'm not mistaken. And that means that you can only, shared array buffer. And how would that work? But if you use shared, okay, hold on. I've never actually used shared array buffer, so I'm vaguely familiar with the concept, but message passing, yeah, and generally not worth it. That's what I was talking about, right? And with message passing, you can pretty much just pass primitives or objects that have primitives as their values. Basically, not, you can't pass functions. So unless your work items are way bigger than that of a collection operation, right? Yeah, and that wouldn't usually be the case. But if you used shared array buffer, could you then, can you pass any type using a shared array buffer? Could the thread access anything at all from the main thread? Or is that restricted again to like primitives? Like I said, I really am not that familiar with the shared array buffer. MDN shared array buffer is just raw memory access. You need to use memory synchronization between threads, just like concurrency works in other languages. Yeah, the problem is I don't know other languages. Not really. I mean, I've fooled around with Python and C Sharp, but that's about it, and not anything with threads or concurrency. The shared array buffer object is used to represent a generic fixed-length raw binary data buffer, similar to the array buffer object, but in a way that they can be used to create views on shared memory. Unlike an array buffer, a shared array buffer cannot become detached. Oh, great. They disabled it in response to Chrome re-enabled it in v67 on platforms where its site isolation feature is enabled to protect against. Okay, that's interesting. All right, so how would that work? New shared array buffer. You tell it how big you want it to be. And then, okay, you still use the same API, post message. And you're sending the shared array buffer as a message, updating and synchronizing shared memory with atomic operations. Shared memory can be created and workers on the main thread, depending on the system, the CPU. It can take a while until it changes propag. Synchronize atomic operations are needed. Okay. All right. I'm going to have to read about this. But that's really interesting. So from what I understand, you can actually are required to be constructed with a new operator. Yeah, I'm going to have to read more about this, but that's really interesting. Okay, so got sidetracked a little bit, but it was worth it. Some interesting ideas and thoughts. There are slightly more high-level mechanisms for that. Well, I know that there's worker threads now, right? In Node, as before you were probably just using either another child process, or you could use like the built-in kind of workers. But now with worker threads, I think the API is very similar to the web workers in the browser. Is that what you're referring to, or? Yeah, but note that whenever you share JavaScript native objects, they do get copied, and that's expensive. Usually expensive enough that implementation parallel collections becomes prohibitive. Oh yeah, okay. So they're still being cloned, even when using shared array buffer, is what you're saying. So you're not really sharing memory then. Oh, okay. So you're talking about just message passing? Yeah. No, for sure. No, I found that like I did some testing a little bit to and I found it was only worth it, or that's the only use case I could find for it, is when you have like a really long, complicated, CPU intensive kind of task to run, and where the input and outputs are usually like pretty simple and primitives. So, if I feed you this, let's say, array of numbers, then you need to crunch it for whatever reason for like 15 seconds, right? Then it'll be worth it. But for other stuff, like I could see, like on the browser or even like a Node app, if you had some kind of online machine learning thing going on, then that could be an interesting implementation, right? Using the threads for that. I've used shared array buffers to implement a fiber thread scheduler that implements a custom work queue with the array buffer. Cool. I understood like half the words in that sentence. Fiber thread. I don't know what that is. Work queue, yeah. The array buffer is still not quite clear on how that works. But what is a fiber thread scheduler? Fiber thread is basically lightweight threads, green threads. That's what powers actors in Erlang, for example. I am really not familiar with Erlang. Note that this is greatly simplified, yeah. Lightweight threads. That's interesting. So what would be the difference between a lightweight thread and just a normal thread? Woo! You can spawn hundreds of millions of those because they have no stack. Interesting. Interesting. No stack. And don't need to integrate with the OS. Huh. And we're talking in JavaScript here? The scheduler then maps OS threads to run the fibers for a particular amount of time. Okay. We're getting deep in CS stuff here. Implements interrupts so that after, say, running 1,000 lines of code, it yields back to run the next fiber. Okay. I think I get it. Interesting. And all of that was implemented in JavaScript? Yes, it's in JavaScript, kind of experimental, though, to see if it's possible, mostly. Seems really cool. Do you have that in a public repo? Love to take a look at it. Post order traversal auxiliary. Move node, transplant, search node. For each. Oh, that's what he did. Okay. I'm just looking at Basarat's implementation here. What I did, it's not public. Okay, cool. No problem. What I did is I implemented an iterator so that you can just use a for loop with my binary search tree. Thought that was pretty neat. But he actually goes ahead and he wrote a for each function, which is just the wrapper for his in-order traversal, which is basically the same thing I'm doing. So it would be interesting to compare the two. So I'm going to do that right now. Let's see. Let's get rid of the set thing, was just for fun. Let's get rid of that for now. And let's bring these back in, except for the remove. We want to have some items in there. By the way, I'm pretty sure you're not benchmarking the collections correctly. It takes some time to kick in. Yeah, for sure. I yeah, so I was thinking about that the other day, right? Because I was doing a few different things and trying different things, and I realized that for some tests, like where the two implementations were like really similar, whatever implementation would come like second would be faster. And then I'd switch them around and the other one would be faster, right? I was like, what's going on there? And I figured, yeah, there's probably some kind of optimization there that's going on behind the scene and it only kicks in the second time around. And that's what I mean. It's like really not easy a native JavaScript implement is going to win out in cases without just in time because it doesn't need just in time. Yeah. So how would you go about testing this more so that it's more precise? Would it have to be like, would I have to run them in different processes? Like, what would be a better way? I was thinking about that, and I mean, I think this way it works for like really obvious performance differences. It'll still show you. But when things get a little closer, that's where I don't have too much confidence in it. But I couldn't really figure out a much better way that wouldn't be super complicated. You need to run a loop. Let the first, say, 1,000 iterations warm up the code. Then measure the time taken for every try and then create a histogram, and then do P99. P99, what is that? I know P90X. Is that is that related to that? Need to run the code, let it warm up, then go do some push-ups. This is some sort of statistics thing. You eliminate outliers. Oh yeah, yeah. Okay, I've heard that before. Um, okay, so here's a question. If you need to run like 1,000 iterations to let the code warm up, um, what about like in practice? Okay, yeah, no, I see what you're saying. Because if your collection is going to be used in an actual running application or program, whatever, at some point, it'll have been optimized properly. Yeah. Okay, but the fact that oh, okay. So, okay, concretely, let's just take a look at, I just take a look at these here. It may be a moving target. Yeah, I have an inkling it might be. So let's just take a look at these two here, where I'm just trying to compare adding insertion to the binary search tree. Um, this is my setup here. So I'm basically generating an array of, well, right now, 1 million random integers. And I am, let's see, after that, I am simply iterating, yeah, here. I'm simply iterating over the array and adding each item. So you're saying, and I'm doing exactly the same thing for both. So are you saying that for both cases here, I should first run this exact same loop, let's say, but without actually benchmarking it, and then run it again, and this time start the timer? Is that what you're saying? And I'll end up having different, possibly quite different results? Let's give that a try. That'd be interesting. Be curious because I can't beat this guy's implementation for adding seems faster, quite a bit faster. I mean, we're talking like fractions of milliseconds and stuff here, but um, by the way, for of has some overhead over raw while loops. Yep, I'm aware of that, but I figure if I use the same, it's going to matter in tight loop benchmarking. In collections, probably not. Yeah. And I'm using the same one, right, in both cases, so I figured it was, as long as I use the same implementation. Okay, so let's try that. Let's see if I was to do, boom, right here. Yeah, that's the thing, the garbage collection, and I think that's what, for some reason, okay, let's, I don't know if you can see this here. These two here, quite a bit slower. And looking at the implementation, our algorithms are pretty much identical. So I don't know what's going on here, but I have a feeling it has something to do with garbage collection or memory allocation or something like that. Because I couldn't find the difference. And the interesting thing is when I test it for smaller number of items, then my implementation ends up being a little bit faster. It's only as we're growing in the amount of numbers that it gets slower. Just attach a Chrome debugger to the node process, and now tell me what exactly that. No, yeah, I'll get to see when the garbage collection triggers. Could try that, but let's first start by doing what you said here. It has a profiler and shows you all the details you want. Yeah, familiar with it. Let's see here. Just want to run this first. So I'm doing, I think, what you said, right? I'm running it like, well, I'm going to be running it like a million times. Oh, but I have to empty it afterwards. So let's do no, actually, I think we both have a quick way to do this. Dot clear, there we go. And I'll do the same thing here. My BST dot clear. All right. Let's try that. See what happens. And then I'll try the profiler as you suggest. Okay. Well, I'm not really seeing a difference. By the way, 99% of JavaScript devs I know have no idea about any of this stuff, so don't stress about it too much. Yeah. No, I'm not stressing about it at all. I'm doing this for fun. Would you believe I don't even work as a programmer? This is all this is all for fun. But I'm actually thinking about switching careers and going into programming. It's just kind of a hard situation because I'm in real estate. I have a good business. Business is really good. It's growing every year. And I'm my own boss. I've got good systems in place. I mean, things are going well, but I just love programming. And I would love to make it my main activity in life. The thing is, I have no work experience, and like I'm gonna go from making, like a lot of money to what am I gonna get? Like even if I know I'm pretty good at it, right? I think. I definitely think that I'm more advanced than like like probably juniors, or I don't even know how you define that. But I know that I I would be more productive, and I know more than somebody that's just out of school, for instance, right? Um, but yet, like if I go to an employer and I've got zero experience, what are they going to do? Start me at like 80K a year, 100K a year? I doubt it, right? So I'm gonna have to start, and I am I gonna get like to work remotely? Because that's what I would like, at least a lot of the time. So I'm probably gonna have to like get some sort of internship or like a really junior position where I'm making like 40, 50K tops a year, working 9 to 5, having to drive there, and but at the same time, I love it so much, and I'm at a point where I need to learn from others. Like I'm doing this by myself, starting to the progress is getting slower, and that's because I can't lean on other people's knowledge, and I don't get fast feedback from just reading articles and stuff. So you say you can get paid very well right off out of the gate if you are seriously good. Where are you located? Well, I don't know if I'm seriously good. I wouldn't even know how to quantify that or qualify that. But where are you located? I'm in Montreal, Canada. I'm at a point where I would consider getting a serious pay reduction and making the switch to actually work in the industry because I like it so much. And I think long term, um, it'll allow me to have income that is not dependent on geography, right? I would love to be able to work remotely and basically be able to live wherever I want, i.e., not in Montreal where it's minus holy crap every winter for 6 months and we don't see the sun. Okay, so I'm not really seeing a difference there. Oh, crap. Yeah, what the heck happened there? Oh no, that's the set. Okay, phew. Never mind that. Yeah, it's about the same ratio. There's not much difference. So either, hmm, I don't know. Be careful. The industry can be really shitty. WRT. WRT. I don't believe I am familiar with this abbreviation. With regard to. Cool. Thank you. With respect to. Okay. With respect to entry level positions, if you're not working on anything interesting, you will be working with low quality colleagues and maybe get stuck there. And some business practices there may turn you off from that eventually. Hmm. So what should I look out for? What should I be careful about? Have any tips, any suggestions? I am open to anything that can help. I can tell you one of the things I'm kind of afraid of. Well, not afraid, but so I've been coding for 3 years, part time, obviously, right? Um, and just for fun. So never actually had any of my code be used by customers on a large scale or anything like that. But I've focused on Node and JavaScript, the Node and JavaScript ecosystem, and I'm getting and TypeScript. I love TypeScript, right? And I'm getting, I think, pretty decent at it. But I realize now, and I've kind of realized that like a year and a half in, 2 years in, um, that most of the work for JavaScript developers seems to be on the front end, and I don't like dislike it all that much. It can be interesting working in the browser and web apps and things like that. I've fooled around with Vue and Angular. I know Angular quite well. I've worked with Angular a little bit and React, but it's the whole HTML CSS thing that's like, man, oh, I like working on I wouldn't say the back end all that much. Like web apps is kind of weird. It's a weird thing because I find the back end is kind of boring. Let me know what you think about this. But here's my kind of my take now that I have a bit more experience and I've looked at a few things. It seems to me that back-end devs working on on like web apps, they pretty much just work on CRUD stuff, right? REST APIs, add this, remove that, you know, find this, and you're just like writing glue code for the, between your database and your front end, and it seems really kind of boring to me. I don't know if I would like doing that day in and day out. So that's for the back end. Now the front end, uh, it's kind of cool because you get to do stuff that you can see on screen, right? And um, I think you get to solve interesting problems. The only problem is that you have to touch CSS. And I, I probably didn't invest enough time trying to learn it. I know some of the basics, but I don't find it fun. It's a pain. There's like 16,000 ways to do the same thing. There's no real easy way to figure out which one's the best one. Um, and it's finicky. I don't know. As I don't enjoy using it, and I probably don't use it often enough where I don't really retain and build on the information that I'm kind of collecting. So it's kind of a pain every time I have to deal with it. There are plenty of people doing that entry level stuff for 20 years throughout their career. Have you done any graphics programming in general, as in 3D stuff or rendering 2D graphics? Not at a low level, no. Like I didn't, you know, write my own shaders and stuff like that. And I've uh, I played a little bit with Unity and with Play Canvas, which is a kind of a JavaScript Unity clone, I would say. So I understand some of the concepts with 2D and 3D graphics and vector math and all that stuff, but it's not like I wrote my own low-level, WebGL style code and stuff like that. No, but I find that stuff interesting. That's for sure. Yeah. Ultimately, it's interesting to realize that HTML DOM, CSS DOM is just a layer on top of renderer that does renders to a window for sure. Yeah, I'm aware of that. Um, it's just the markup and the way it works. Like if we just take for instance the Unity framework, I find it a lot easier to do graphic stuff in Unity than I guess it's not fair because we're comparing building user interfaces, which is what the DOM, the browser is good at. We're comparing that to dynamically moving objects on a screen. I guess it's not the same, and there's a canvas now in the browser, but yeah, when I first started out and I was writing like little games in JavaScript and little programs in JavaScript, I would use the canvas and what was it called? This little graphics library. Oh, what was it called? I think it's a Java port. Oh, what is it called? drawing a blank. Processing JS, I think it's called. Processing or processing.js, is that? Yeah, I think so. Yeah, yep. See, look at this. Beautiful. Yay. Well, that's fun stuff. And I find it so much easier using a library like this than CSS to get this kind of result, right? The thing is, it's probably not optimized for the browser like code can be using HTML and CSS. So for the first little while, that's pretty much all I use to do graphic stuff in the browser. Well, JavaScript is a programming language. You can build a small virtual DOM engine or a small compiler that allows you to write the front end in a language you like and transform. Yeah, transfer. Sure. Yeah, I can do that. Yeah. I can build my own, my own interpreter or compiler. Basically, make up my own language where, I like to work with, and then write a parser, and no, first a scanner, a parser, then a compiler that compiles the whole thing to HTML, CSS, just so I don't have to deal with HTML and CSS. But to write this properly, I would have to know HTML, CSS really well, which that's funny. Yeah. It was meant seriously, really? It's really not that much work. The trick is that it forces you to learn it and eliminate it being boring. That's not crazy, actually. But it seems like it would be a lot of work, though. Maybe it wouldn't be that much work for you, but I think for me, it might be. Like we're not talking like a week's worth of part-time programming here. We're talking probably like a few months, right? To get to anything that's usable and not full of bugs and well, you can write something like that in a day or two. Really? Really? Okay, maybe if you've written something like that before, but I haven't. Not necessarily production level. Well, that's cool. I'd be the only one using it, but still. Well, I guess if your language, the language that you're inventing is really simple. But speaking of which, like a few weeks ago, that was like a really cool project. I don't know if you know about this. Let me show you. I think I've got enough tabs open here, man. Crafting interpreters. This guy called Bob Nystrom, he wrote this book, which I read, and I thought it was pretty good, Game Programming Patterns. Read that like a few years ago, and it's available for free online. He puts his stuff out there for free, although you can also buy it, I think. But anyways, he's working on this book here. It's not quite finished, but he's got a lot of it done. That basically walks you through crafting your own interpreter for a made-up language that he calls locks. It's very similar to JavaScript, a bit of like a cross between JavaScript, Java, and Python, I guess. But anyways, he walks you through the entire thing. Scanning, parsing, evaluating, statements, blah, 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 blah. First, you do a tree walk interpreter. So just using what is that called again? Something recursion something. Anyways, basically using recursion to go down the parse tree, the syntax tree. And afterwards, and that part's not complete, but he gets you to write an actual bytecode virtual machine in C++. So I did this, I completed this. He gets you to do it in Java, but I did it in TypeScript. That was fun in Node, and it works. It worked like a charm. And I was thinking of doing this part here in the Rust. I've been wanting to learn Rust. I figured if I'm going to learn a low-level language, I'm more interested in Rust than I am in C or C++. So, anyways, so I don't know, and I went through this, and I just basically it was like paint by numbers, right? You just kind of followed along, and it still took me a while to do, and it's not a complicated language. So I don't know how I would do that all on my own in 2 days. Like invent the language, then, kind of figure out the grammar rules properly, then write the scanner, then, the parser, and then evaluating. Eesh, I don't know. You're probably much faster than than I am at this. If you think I can do this in 2 days. It would be an interesting project, though. There's no doubt about that. I was implying a super simple language, of course. Yeah. Problem is like, how simple can a language be in order to, be expressive enough to represent stuff that's going to go on screen? And I don't know, I'm not seeing it, but I could think about this some more. Now, what I want to try is that famous for each. For each, and our callback is going to be doing absolutely nothing. That's going to be our callback. Just want to test the iteration. 1,000,000 times should be enough. 1,000,000 items, or roughly. My BST for each. I don't know. What am I doing? I didn't implement. I'm just going to use this. For item of BST, my BST. Oops. Okay. And I'm also going to do absolutely nothing. See what we get. Okay, forgot to change the names. We're just going to call that iterate. Iterate. And you don't need a full-blown language with a parser. Technically, you can just create data structures with a shallow embedding that yields the behavior you want. Yeah, I think I get what you're saying. Especially if it's a simple language. All right, let's run this again. All right. So I'm a bit slower. Now this might be because I'm using the for loop, but I mean for a million items, it's really not that big of a difference. How did he implement this for each again? He's just... Did I skip it? Did I skip it? For each. There it is. It's basically calling, it's just a wrapper over in order traversal. In his in order traversal, where is it? I skipped it. There it is. Mm-hmm. Oh no, that's not the same. Okay, so he's using recursion here. But in order traversal, where is it? Oh, there you go. Is also just a wrapper over this in order traversal aux, which takes the callback. Stop false. Interesting. Anyhow, I think I'm not gonna fiddle with that too much. So, do you have any tips for me in terms of if I actually want to go out and look for some interesting work? Seeing that I have no previous work experience in programming. I'm about 40 years old. I'm a relatively smart dude, I think, but, you know, how do you prove that? I think I asked earlier, what are your goals really? Yeah, I guess you could say my goal is to, as quickly as possible, find a job where, or even if I, actually, you know, ideally, if I could do this freelance, if I could be my own boss, that would be interesting too. But anyways, so I'd settle with what I really want is to be able to program every day, make money from that as much as possible, obviously, and be able to do that from wherever I want in the world. So that's my goal. Program, interesting stuff, lots of money, anywhere in the world. Right? Hey, you asked. That's what I would like. That's what I eventually would like to work towards. Don't expect to be able to start off that way, but as quickly as possible would be nice. Oh, I think he has a height. That could be an interesting function to add. Is empty, I already have. Size contains. The easiest way to get into real freelance is by getting someone to vouch for you, which you could, for example, do by making a significant open source project or significantly contributing to one. Yeah, which is easier said than done when you don't have much experience. I kind of feel like my best shot at getting to where I want to get is to actually get some work experience, get to work with other programmers, you know, who have done this for a while, that can actually show me some stuff. I can get some, you know, live feedback when I have questions. Because I mean, sometimes there's like certain concepts or I have certain ideas, and I'll waste so much time trying to look up the answer, Um, and then it won't be exactly the answer I'm looking for. It's something that's kind of related to that, and I have to kind of, figure out how this applies to what I'm working on. And I'm thinking that if I had like other people that I was working with, I'd save a lot of time in terms of learning. I would learn faster because I'd get customized feedback and quicker feedback to the work I'm putting out, to some of the questions I might have. I would also be exposed to a broader range, I think, I hope, of things. I can tell you that compared to many other devs I have seen, I so far see apostrophe. Oh, right attitude, motivated, etc. Well, good, thanks. Now show me the money. Yeah, well, I mean, I am passionate about it. I truly believe I found my life's passion. Took me, you know, 36 years to get to that, but I've never stuck with something this long and never, my interest just keeps growing. Hasn't waned at all. Haven't looked too much into actual work or knowledge, but I think you can make it. I, I'm an optimist sometimes. So I also have a good feeling. I just wonder what I would end up with. I'm doing the 100 days of, what's wrong with my camera, man? It's just, can't get it to, yeah, I'm doing the 100 days of code challenge. I'm at day 60 something. I think once I'm going to be done, I'm seriously going to think about polishing my resume and, sending it. I also have contacts in the industry. I have a few people that I know. One of them actually has his own shop, like a small dev shop. And I think he'd be interested in hiring me. But the conditions, I don't know, right? And what I would be doing exactly, I don't know. We'll see. And that's that. Am I following you on Twitter, Lumi33? Are you on Lumi Elite, right? Yeah, that's right. Are you on Twitter? Am I following you on Twitter? Twitter. Can't even spell Twitter right. What's going on? I'd love to follow you on Twitter if you are. That's cool. No worries. I totally respect that. Oh, so I guess it is you. And I just showed it to my huge audience of 2 or 3 people. I wouldn't be too worried. But here. But I mean, if you're not posting anything, I won't bother following you. Unless you want me to. I'll do whatever you want. All right. Fair enough. Fair enough. If you want, you can follow me though. I post my progress on the 100 Days Challenge and sometimes interesting things and questions. Okay, let's just turn it off. Well, I'm gonna have to go. I actually keep those sessions to 2 hours, and I'm close to 3 hours now. It was just so interesting chatting with you. I figured I'd just keep going. Have you stopped by my channel before? Hey, cool. Thanks for the follow. To array. Oh yeah. See, the fact that I have an iterator makes it so that I don't have to implement this or that. I can just do my BST. Actually, I can just do this. Boom, boom, boom. There we go. How cool is that, eh? What do you prefer, this or that? Bassarat BST.toArray. Boom. I like this. Height, there it is. That could be useful. Well, I can see it being useful internally. Would it be useful for, when do we need to know the height of a tree? As the user of the tree, of the collection. Don't know, I'll have to think about this. Search node, already have that. Transplant, don't need it. I'm using something different. Remove node. Okay, this is all private internal stuff. By the way, these kinds of B trees are rarely used in practice. Yeah. I figured, because I never see them. So, especially since they're not balanced, right? Oh, there you go. It doesn't even look like it auto. Yeah, it doesn't. His implementation doesn't. He's using it as a map, basically. It's like a sorted map. He calls it BS tree KV, but it's basically a sorted map, and it's not balanced. I saw that. My idea was just, I'm going to start by just doing a binary search tree. I've never done it before, so I'm just doing the plain thing. But then what I'm going to do is maybe use that as a base class to implement like a red black tree, or even better, I think, is a what's it called? VST, VS, AV, Avia, Avia. It's some sort of acronym. It's basically a red black tree, but better, from what I understand. Oh, there's one here. I always AVL trees, right? AVL trees. So that's my idea. Eventually, I want to end up with that. And I'm going to use that. I'm probably not even going to use it directly. I'm just going to wrap some sort of sorted map around it. I mean, in terms of the API. So from the outside, you won't even know that you're dealing with a tree. Maybe like a sorted set, sorted map kind of thing. We'll see. This guy has, he's got, oh yeah, this is what I was surprised with. He implements, yeah, red black trees are most common. Yeah, they are, because they've been around for like 40, 50 years. The AVL trees are fairly recent, like in the past 10 years. And they're just an improvement on the red black trees. But it depends on usage scenarios, how many updates, how many searches. Yeah. And the thing is, again, I want something that's fairly general use, right? So I'm gonna have to think about that and see exactly what I'm gonna do. But yeah, I just for kicks, I don't know if you noticed, but oh, I think I deleted it, but yep, I did do some performance testing with a sorted, see, sorted integers, and man, phew. Yep, that's where you can see that it's important to have a balanced tree. If you only construct a data structure once and then search a lot, hash is probably better. Let's think about this. Well, yeah, right, because you can just you could just populate your hash, and then sort it, and then you have a sorted hash. Is that what you mean? Because if we're talking about dealing with a sorted data structure, right? So, yeah, for sure. Or even an array, depending on what you know, if you need to access by keys or not. But yeah, definitely. If all you do is populate the data structure and then you never add anything else to it, then yeah, definitely. Yeah, that's true. Yeah, most collections are small, which makes the whole performance thing kind of a who cares, right? Um, but I mean, I figured I would implement my own collections library just for mostly for learning purposes, so might as well try to do it right. And I do like to, I do a lot of right, puzzles and exercises and katas and stuff like that. So you do get to use some, a bit more CS stuff, a little bit more, and sometimes you need bigger collections. So I'm keeping that in mind as a use case for this library. So the O factors are relevant often. You rather look for small constant factors. Yeah, that makes sense, of course. They would never build a database or anything in JavaScript. Yeah. Has anyone ever done that? An actual database in JS? I mean, I guess you could, right? So databases that actually run like they have a node runtime, right? Not the kind I'm talking about. Yeah. Hmm. Interesting. So that's a good point. A key value stores technically. Oh yeah. Well, I meant like a persistent, not a in-memory database. Because yeah, if you're talking about in-memory databases, I know of a few, but databases that actually write to the file system. Yeah, I'm sure someone has done that. That's kind of depressing, by the way, realizing that it's pretty much impossible to have an original thought. That everything that can be done in JavaScript has already been done in JavaScript. Not will be done. It has been done. Everything, every idea that I have, I'm like, oh, wouldn't it be cool to do this in JavaScript? This quick npm search. Damn, someone's already done it. Oh, here's a perfect example. Okay, I flipped out for that. So I showed you the crafting interpreters book, right? Um, so I figured, hey, I'm gonna write the interpreter for that made-up locks language. The guy made up his own language, right, for the book. And just for fun, I'll write a VS Code extension for it, right? So I never thought someone would have, done that, but they did. And the book is not old. Like it hasn't been out for like years and years and years. So that was kind of a depressing moment for me. Like, man, I really thought I had the one idea or no one would have done it. And like, someone has. Okay, well, when I built my fiber implementation, I didn't find any package or paper on it. There are certainly novel things that haven't been done. Yeah, no doubt. I know I'm exaggerating a little bit. They seem to be hard to find. Probably lack the breadth of experience too, to think of, what could potentially be done that hasn't been done before. All right, friend. I think I really have to go this time. So then get all that much coding done, but a lot of interesting ideas were exchanged today. Thank you very much for that. No, that's quite all right. That is quite all right. Enjoyed our interaction. You brought some really good points. I learned. This is why I'm doing this, so I'm quite happy with this session. Do you have maybe a suggestion as to where I can take, knowing my goal with this library? I want something that's, general purpose. It'll work well with small collections or bigger collections. No matter what kind of type you're trying to shove in there, it'll have not the best performance, but good enough. So what do you think I should implement next? Or even maybe what else I should shove into my binary search tree class, or any cool ideas that would be useful? My experience, JavaScript devs tend to not use any such libraries. If you are looking for practical, that's complicated. Yeah, now that's a good point. I have no expectations that it's going to get widely used in the JS community. They would just use arrays mostly, for sure. That's what I've seen. Yeah, I am not a fan of the API. Yeah, same. There you go. I was typing it as I was saying it. Persistent data structure that has a good TypeScript API. Yeah, like the idea, immutable.js ideas, I think is pretty rad, but I've played with it, and man, the API just really annoyed me. But Yeah, we'll see. Speaking of trees, right? Isn't pretty much everything in immutable.js implemented as a tree? Because you're basically, yeah, right? You're never destroying anything. You're not mutating anything. So you're creating a new instance every time, but you're not actually creating a new instance because that would be crazy. It would like memory. So I think what they're actually doing is like building some sort of a tree of properties, and you're just adding on to that as something like that. There are a few ways to make it happen, but the good persistent data structures implementations tend to be quite complicated. They use trees inside. Yeah, that's right. That's what I understood. So who knows? Maybe my doing this here is a stepping stone towards implementing some kind of persistent data structure or library. All right, I really have to go, man. This was fun. I hope to see you again. I usually stream every weekday at 9 a.m. from 9 to 11. That's what I usually do, except for Fridays. So tomorrow is going to be at 1:30 p.m. Eastern time. I'm on the Eastern Coast, Montreal, right? I told you. All right, man. Thanks for sticking around and chatting with me. Hope to see you again.